Hello everybody. Now coming to the next chapter, diagnostics for battery management systems. All right. So previously we saw high voltage systems. Now we will see battery management systems. Now coming to the diagnostics of battery management system of electrical vehicles play a central role in monitoring, controlling and ensuring the safety and efficiency of high voltage battery pack. Understand this very carefully. This monitors and keeps a vigilance on the battery pack. And since BMS is the brain of the battery, it is the its diagnostic capabilities are vital for detecting faults, preventing hazards, supporting regulatory compliance, and enabling predictive maintenance. Okay, now what is meant by battery management system? The battery management system is embedded control system that monitors battery parameters, voltage, current, temperature, SOC, SOH. Alright, I already told you what these acronyms stand for. And battery management system, it controls the contactors, cooling systems, balancing circuits, and it also protects the battery from unsafe conditions. Always protects the battery from unsafe conditions. Now, when it communicates with other ECUs via CAN or Ethernet, performs self-diagnostics and system level diagnostics. All right. So this is extremely important. These are the extremely important rules or actions of BMS. Now, when it comes to BMS diagnostic objectives, the purpose in this table we will see the purpose and description. Okay. Now, the purpose is first purpose is safety. It detects hazardous conditions, the thermal runaway, or current to take protective actions. And when it comes to reliability, ensure consistent performance over the battery life cycle. Now coming to compliance, meet OBD functional, the compliance it should meet the OBD, it should meet the functional safety and also it should meet the EV regulations. Now coming to serviceability, it should enable the detection, logging and communication of faults for repair and maintenance. So the ease of repair and maintenance is extremely important when it comes to serviceability. Now when it comes to prognostics, support aging and degradation analysis via state of health and predictive algorithms. Okay, so these are the main objectives of BMS. Now, what are the key diagnostics functions in BMS? All right, so let's see what are the major diagnostic domains of typical EV BMS. All right, the first diagnostic function is cell and module voltage diagnostics. So understanding the cell over voltage, under voltage detection. It detects the cell over voltage and under voltage and it protects the cells from damage and degradation. Now when it comes to typical thresholds, greater than 4.2 volt and less than 2.5 volt for lithium ion chemistry. Okay, now when it comes to cell voltage imbalance, it indicates the balancing failures or degraded cells. All right, to further open wire detection, objects faulty sensing lines between BMS and cells. Okay, so it detects the open wires. And next is it also keeps a close eye on the voltage sensor, internal consistency checks, redundancy based comparisons. Now, to further talk about the diagnostic functions in BMS, next is temperature monitoring and diagnostics. One is cell over temperature and under temperature, critical for charging safety and lifespan. Thresholds vary based on the chemistry. Again, the temperature can span between 60 degrees centigrade and minus 20 degrees centigrade. And coming to the temperature sensor failure, the open short detection on thermistors, the cross verification with neighboring sensors, thermal gradient checks, and even heating example, cooling system failure or cell defect. Okay. Now coming to the current measurement protection, the first is overcurrent detection And next is when it comes to detect the overcurrent, it charge discharge limits of 2 coulomb or 3 coulomb. These are the charge discharge limits that must be detected. Now, when it comes to short circuit diagnostics, the instantaneous detection and isolation. Now, coming to the current sensor faults, drift detection, cross verification with shunt Hall sensors. All right. So these are the when it comes to current measurement and protection, these are the three things that must be monitored. Now, coming to contactor and pre-charge circuit diagnostics, contactor stuck welded, checked via voltage before after switching. And now, when it comes to pre-charge failure, diagnostic of pre-charge resistor and relay. And now, when it comes to contactor command mismatch, relay commanded on but feedback missing. So these are the various aspects that can be diagnosed on a contactor and a pre-charge circuit. Now coming to high voltage isolation and HVIL diagnostics, insulation resistance monitoring. It ensures HV system insulation from chassis. Now compliant with ISO 64693 and HV interlock loop HVIL acronym faults. Now detects the tempering and connecting connector issues. Okay. To proceed further, self-balancing diagnostic, whether the self-balancing is happening correctly, accurately or not. Now, when it comes to balancing circuit fault, failure in passive or active balancing. Next, when it comes to ineffective balancing, detectable by persistent cell voltage imbalance. Now, coming to state estimation error, which includes the state of charge, state of health, SOP, or state of power. The state of charge is drift or mismatch. Sudden SOC jumps or inconsistencies with the pack voltage. This has to be thoroughly monitored. And when it comes to state of health degradation, predicts aging related capacity loss. And state of power limits and reduced power available to health safety. Now, when it comes to communication diagnostics, CAN or Ethernet communication loss. All right, communication faults like timeout, checksum redundancy, cycle error, or ID mismatch. These are all the various faults that can happen, and these are the various faults that need to be thoroughly monitored. Now, when it comes to faulty sensor communication, SPI, I2C, UART bus faults to sensors and or balancing ICs. And when it comes to inter-ECU communication loss between master BMS and slave cell supervisors. Okay, so these are all the various aspects of communication diagnostics that need to be monitored. Now, when it comes to internal software system diagnostics, the various areas like RAM, ROM, EEPROM, self-test, memory integrity, and in this RAM, ROM, and EEPROM, memory integrity and storage corruption checks must be monitored or thoroughly checked. And when it comes to watchdog timer expiry, detects softwares, hangs or deadlocks. Now, when it comes to task execution, time overrun, critical in real-time scheduling for safety. Critical in real-time scheduling for safety, and this is common for DTC and fault code. All right, so with the help of UDS or OBD, this common DTCs and fault codes are detected. Now these DTCs are logged and transmitted via UDC protocol or ISO 14229 on CAN and or Ethernet and are used by scan tools for fault diagnostics. All right, again on the right side you can see the various kinds of codes: P0AFA, P1A10, P0A6, P1E00, P0A80. All right, describes hybrid battery system voltage, battery cell imbalance detected, and comes to isolation fault, battery contactor stuck close, and replace battery pack. All right, now These are the various types of diagnostic testing approaches. First is continuous monitoring, which ensures real-time parameter validation during the drive. Next is self-diagnostics, um, which means built-in self-test at power on. End of line testing, which means functional safety testing at the manufacturing. Service diagnostics, which include the scan tools, and over-the-air monitoring, remote diagnostics, fleet data aggregation. Now, when it comes to hill simulation for validating software against fault scenarios. All right. So these are the various types of diagnostic testing approaches as far as electric vehicle is concerned and as far as the battery management system is concerned. Now coming to the functional safety and cyber security, BMS must meet ASIL C or D levels depending on application, and diagnostic coverage is mandatory for safety goals. All right. Now, diagnostic interfaces must be secure to prevent spoofing, unauthorized access, or malicious firmware injection. Malicious firmware injection. Now, when it comes to tools used in BMS diagnostic development, vector cano canalizer, ETAS, INCA, communication and calibration. And next is DSpace, or Nation Instruments PXI or AVL, which cater to the hill test setups, and tools like MATLAB or Simulink, which take care of the model-based diagnostics. Python Excel, data logging and validation analysis. OBD scaling tools like Bosch, Snap-on, OEM specific devices. All right. Now, when it comes to summary, the role of diagnostics in BMS. Now, when it comes, what are the role of diagnostics to summarize? When it comes to safety, prevents thermal runaway. When it comes to battery health, tracks aging and predicts failures. And serviceability, fault logging and DTC reporting. And when it comes to functional safety, it detects the faults per ISO 26262. And when it comes to OBD compliance, report standardized trouble codes and vehicle performance, enables accurate SOC, SOH, and SOP estimates. So these are the various aspects that are monitored by the diagnostics as far as BMS is concerned. Thank you.